trig functions as we go through doing various things. It's kind of like in Algebra 2 where you learn how to solve a quadratic, you learn how to factor. Well, then from that point forward, anytime you see a quadratic, it's assumed you know how to factor, that you could solve it if it needs to be. You see what I'm saying? Same kind of thing with the trig identities. They'll just keep popping up over and over and over. And it'll be, oh, yeah, that's a trig identity. I need to use that to do the calculus. So again, this is not calculus. It's the trig that you need to do the calculus, if that makes sense.
My
All right.
question is,
Yeah.
is 1/10 the same thing as cosine of sine? If they both equal?
Yes.
Okay.
Yes.
Got you.
You mean sine over cosine?
No, because I'm talking about cosine.
Yeah, but
Have y'all ever done a circuit before?
No, ma'am.
I love them.
You're making my little brain hurt, right?
We're gonna start them together and we're gonna see where it leads us. These are so much fun. And you probably don't think so, but
I like these ones. I remember how to do.
we were working. I was telling Noah this yesterday. I had one. I thought it was the review, but now that I think about it, I think it was volumes of rotation.
It was.
That everybody struggled with. And I ran a circuit for it because I love Verge. Verge is the one who makes these. Y'all hear me talk about Verge a lot. I love it. But she does a really good job with them. But you really have to understand, but it works its way around and makes its way back. But Miss McIntyre and I sat here with that volumes of rotation one because I got halfway done and I made a careless mistake and I could not find my mistake. So it's a self-check to know that you got the right answers too. But before we do this, as promised, I was supposed to do this on the first day and I do apologize. I want to show y'all a little video.
yay.
And I showed this at the very beginning, halfway through, and then at the end last year. And it's funny to watch your faces at the very beginning because you go, what the heck are they talking about? And then midway through you go, wait, we've done a lot of those. And then at the end you go, oh my gosh, I can do all of that.
I feel like this is gonna scare us.
No, it's okay. So the reason I appreciate this so much is because I have done the video projects with you all, and y'all did really good jobs with them, and I love the video projects. So this is an end of the year video that, I mean, these people, like, I think every calculus class shows this video, but they're culminating final project because you have to have we don't have a final exam. I mean, we do. We have to give you a final exam, but anyway. This was their final project for calculus 12 years ago. No. I hope y'all love it too. Listen, these kids nailed it. I can't skip the ad, I'm sorry.
The Delta variant.
See, that's what.
Oh.
That's what Joseph said.
Oh, I think I see it.
But anytime I try to play another song,
So there's actually, you say, what do they look like now? Yeah, there's one that, oh yeah. Just so you can see, I won't play the whole thing. Just so you can see what they look like. We watched this last year at the end of the year. There they are. Anyway, they go through now. They don't do anything with math in their careers now. Remember, I think one's like a cop and one's. Anyway, that will mean a lot more to you as we move through. You will understand, but it's really good. It's one of my what?
Lucy says something she'd like to comment on. Do you mind if I get some more?
What? All right, let's get your circuit. Let me show you how this works. You want me wait? I'll wait on you. Go.
Yourself and how much.
All right, let's look at number one. Look at number one. So number one says cosine A plus B, right? All right. No, that's not the answer. The answer is not where it says answer. All right, so what we're going to do is we're going to expand this using trig identities any way we can. Try to manipulate it to make it look another way. I shouldn't say simplify. I should say we should try to manipulate this to make it look another way. So as you familiarize yourself with these trig identities, if you look at the sum and difference identities, the very first line there under, you have a sine A plus B and a cosine A plus B. So here the cosine of A plus B equals what? So I'm going to look for that answer. Somewhere on this circuit, I'm going to look at all the answers, and I'm going to see if any of them are cosine A, cosine B minus. That's where you go for the next one. Okay, so if you turn over on the back, nope. I haven't done it. I started it, but then this is not the one I started.
It's on the back, middle left.
Yes. Midway's down on the back. See at the top it says answer, cosine A, cosine B. So so that would be number 2. No, that was number 1. Yes, number 2, you're right, number 2. All right, so in that blank, see it says answer is this, and then it says number blank, and then it has another problem. Sine of pi over 3, cosine pi, blah, 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 blah. So this says 2. So now you're going to work this one. You're going to work problem number 2 now, which is plus sine pi cosine pi over 3. So I'm going to look at this and I'm going to say, okay, well, what does that equal? Well, these look like exact values on my unit circle. All of these may not be trig identities. This is to bring with the unit circle too. So as I look at this, what's the sine of pi over 3? Quick. Square root of 3 over 2. What's the cosine of pi? -1, so I'm going to multiply that by -1. To that, I'm going to add, what's the sine of pi? 0. What? What's the cosine of 1/2? So this would give me negative square root of 3 over 2. So now I'm going to go through I need to mark this. 2. Now I'm going to go through and look for negative square root of 3 over 2 as one of the answers. Because the cosine of pi is -1. You with me? Not as bad as you thought it was going to be. That's good. So far. We have a long way to go. All right, so be very careful. Well, we're going to look for it. We're going to see if we see it. And I do see it. Yep. And be careful because I see a positive root 3 over 2 and I see a negative root 3 over 2. Make sure you choose the right one. Because in order to do this correctly, if you do it correctly, every box should be filled in and your very last square should bring you back full circle. You should end up back at number 1 when you're done. Like this, the answer in box number 1 should be the answer for the very last problem you do. Yep, and so go in order. Okay, so, of course. So negative square root of 3 over 2, so that's number 3 now. And now I need to do sine A cosine pi over 3. And anytime you start seeing specific values in there, those are coming from the unit circle, right? So this looks like a 2-part thing maybe. Maybe this is a trig identity as well as using some values from the unit circle. What's it could be. So which one gives you a sine and a cosine that you're adding together? Sine A plus B, right? So really this is the sine of A plus pi over 3. That's the way I would read that. Now, if that's not one of your answer choices, you might have to manipulate it a different way. Right. Did y'all see that on here?
No, I'm sorry. Wait, first of all, why did you say wait? Why did you say?
Yeah, so what I did on that one, well, and so it could be that some of them I need to do that. This is just to kind of get you familiar with the different ones. As we start manipulating things, you'll see you might start doing it one way and then go, nope, that didn't give me anything I needed. Let me go back and do it another way. So maybe you looked at this and the first thing you said was, well, I know the value of cosine of pi over 3, but then you look for your answer and it wasn't anywhere on here. To me, if I see this, I recognize that, but I've done a little more with the trig identities, but I recognize that being an identity. The expanded form of the identity anyway, right?
Like whenever you're expanding and then you're solving.
Wait, I don't know.
They're trying to change his form basically,
Yes.
but like.
Make it
do
look
we
a
actually
different way.
solve-
Well, honestly, I mean, you do, but the more you use them, the more they pop out because they're very similar. The sum and difference and the double angle are the ones that are the most confusing because they start looking alike. Like if you look at the sine of a plus b and the cosine of a plus b, they both expand out very different ways, right? But you would think they would expand out the same way, just saying change the sine to cosine, right? That would make sense, but it doesn't. We're not going to derive them in pre-cal. You should have gone through why they are what they are and proving the identities. We're not going to do all that. You did? Okay. But if you didn't, it's okay because at this point now we're not going to explain them all and go into all that detail because that would be a couple weeks worth of stuff going through on the trigger. Where I'm just going to give them to you and tell you to be able to use them. You said it was square root of 3 over 4 plus square root of 3 over 4. Because they have common denominator. I don't know. They just asked me this. I don't know what number it is. It's 4. Because they have the same denominator. Let me start from the beginning. All right, 4 is cosine 30. Is this where y'all are? All right, sine 30 plus cosine 30, sine 30. So you could do this a couple different ways because these are exact values on your unit circle. You could go through and just say, what is the sine of 30? What is the cosine of 30? Is that what y'all did? Yeah. Multiplied it together. It's also an identity. Right. So, right. You could do it either way. If you did sine of 30 plus 30 using that sum and difference identity, then this is the sine of 60, and the sine of 60 degrees is the square root of 3 over 2. Again, you don't have to do it that way. If you did it and you said, wait, these are all exact values and I know what they are. What is the cosine of 30? What is the sine of 30? And then the cosine of 30. So you get the same thing. But the question was, so here's the answer, but the question was, how did you go from this to this? So I have the square root of 3 over 4 plus the square root of 4. And because they have the same denominator, I can combine the numerators. But then you said, well, how do I add square root of 3 and square root of 3? Well, how do you add x and x? 2x. So I have 2 square root of 3's over 4. And now the 2 and the 4 simplify down to a half. Yes. Yes. To make dollars? I'm just kidding. I'm really sorry.